Hi everyone. In this video, we will talk about how we can set up and solve word problems. So why are we solving word problems? Why is this important? And if you read this little paragraph, you can see that there are several different ways in which we have equations and word problems relating to math in our everyday life. So, for example, if you're making a recipe and it only serves three, but you have six people coming over for dinner, so you have to multiply all of those ingredients and measurements by two when you're doubling it. So, that is an example of using a mathematical model in your real life, everyday life to make sense and help you in accomplishing a task. So we can create mathematical models for several different contexts, and this is when math is its most useful, when we can apply it to our everyday life, something that we will be using, not just as random equations that we're practice solving in class or different expressions or things like that. This is where we want to apply our math. So when we are working with word problems in this class, we're first going to be focusing on mathematical models that are using linear equations to solve our word problems. We have not yet talked about quadratic or rational or things of that nature. So in this section, we are only worried about linear equations. And in this class, we're going to be dealing with a lot of financial situations. And when we're given a word problem, it's written in English. And we need to start thinking of math as its own language. And so when we're reading a word problem, we're trying to translate between the English that is given to our math language of operations and numbers and variables. And so as we're reading a word problem, we can consider these steps to help us make sense of what we're working with. So in step one, we want to read the problem carefully. You may want to read it a couple times to make sure you're getting all the information you need and what the problem is actually asking. So some tools that can help is if you're underlining or circling or making a list of that important information that's given in the problem and what it's asking us to look for. And then also, if we have anything that is unknown that helps us figure out what's being asked of us, to assign a variable to that. So X is the most common, and that's what I'm going to be using, but it could honestly be any letter of the alphabet. In step two, we're going to, if we have to, and we'll see an example of where this step isn't always necessary, but if we need to, we're going to write expressions for any other unknown quantities that rely on our variable x and what that represents. And we'll see what I'm talking about in just a second with our example. Step three, we're then going to write an equation using those expressions from step two, or what we observed in step one, that helps us model the information of the problem. And again, this is all going to be in terms of our variable x. Finally, in step four, we're actually going to solve that equation to help us answer the problem's question. And step five is that solution that we got in step four accurate? So checking that solution in both the equation we have written for ourselves in step three and in the original wording of the problem. Does our answer make sense? So here we have our example. It says you are choosing between two gyms. One gym offers a membership fee of $50 plus a monthly fee of $20. And the other gym offers membership for a fee of $5 plus a monthly fee of $35. After how many months will the total cost at each gym be the same? What will be the total cost for each gym? So we have two questions that we're trying to answer here. So the first one is we're looking at how many months will the total cost at each gym be the same? And then we're asked what will be the total cost for each gym when they are equal. Now, some information that we are given is one gym, which I'm going to call Gym 1. They have a membership that's a fee of $50 plus a monthly fee of $20. And Gym 2 is giving us a membership for a fee of $5 and a monthly fee of $35. So let's go ahead and write this down in words, help us make a list of what we know. So gym 1, we have $50 initial cost, and then we're charged $20 a month. In gym 2, we have our initial cost of $5 and a $35 fee every month. The last thing I had mentioned was about an unknown. And so one thing that I will notice is unknown is we're asked how many months and the total cost at that amount of months. We don't know how many months, so we're going to say that is equal to our variable x. So now using this information, we're going to write some expressions to help us know and calculate how much each gym is going to cost after a certain amount of months. So for our first gym, we have a $50 initial cost. And so when I think of an initial cost, I think it's one time. It's at the beginning of this, and you won't be charged it again. So that doesn't rely on how many months you're a member. But the $20 a month fee does. So it'll be $20 every month. So 20 times the number of months you're a member. And for the total cost, we're adding those two together. For gym 2, again, we have an initial cost, a one-time fee of $5. But then we have $35 we're paying every month. So 35 times x, and to get the total cost, we're adding those together. So now we're going to move on to step 3. And here we're asked to find how many months until the cost is the same. So remember, that is our first question that we are given in this word problem. And so we're looking at when these gym memberships will cost the same amount or when they're equal. And so in order to find this, we need to set our two expressions from step 2 equal to each other. So gym 1 was 50 plus 20x, and gym 2 was represented with the expression 5 plus 35x. Step 4, this is when we solve our equation. So we are going to make sure that when we're solving an equation with an unknown, we move every term with our x's on the one side, and then we want everything else on the other side of our equal sign. So the first thing I'm going to do is I'm going to move my x's to one side. So I'm going to subtract away this 20x. And remember, what I do to one side, I have to do to the other. So in this case, we're left with 50 on the left-hand side. And on the right, we have 5 plus, and 35x minus 20x is going to be a positive 15x. We have this constant 5 with our x term, so I'm going to get rid of that by subtracting 5 on both sides. So 50 minus 5, we get 45. And then on the right, we are left with our 15x. I want to undo this multiplication of 15 times x, so I'm going to divide by 15. Remember, what you do on one, you do to the other side. 45 divided by 15 is 3. 15x divided by 15, that is x. So according to this relationship, we know that after 3 months, the gyms are going to have an equal cost. So remember that the second question of our word problem was asking us to find that cost when they are equal. So in this case, how much does each gym cost at 3 months? Since we know that they're the same at 3 months, I can choose whichever one of these expressions to plug in 3 for my x. So I'm just going to use the one on the left for gym 1. So we have 50 plus 20x. I'm replacing my x with 3. So we get 50 plus 20 times 3. Remember, order of operations, I have to multiply first. So 20 times 3, we get 60. Adding those two terms together, we get 110. So what this tells me is at 3 months, Gym 1 and Gym 2 cost $110. All right, so now we've found a solution, but let's check to make sure that it is the correct solution. So what I'm going to do is I'm going to plug in 3 for my x in my original equation from step 3, just to make sure that that makes this statement true. I get the same thing on both sides when I work this out. So we have 50 plus 20x equals, and we're hoping it equals, 5 plus 35x at x equals 3. So I'm going to plug this in. So we get 50 plus 20 times 3, and then 5 plus 35 times 3. One thing I'm going to do, because we don't know that these are equal, I'm going to draw a line down the middle so that I'm only manipulating one side at a time to make sure that what I get is the same as what I would get on the other. So again, you're going to do your multiplication first. So 20 times 3, we get 60. Doing our addition, we get 50 plus 60 is 110. On the right-hand side, we have 5 plus 35 times 3. Well, 35 times 3 is 105. We add our 5 and we get 110. So these are, in fact, equal at x equals 3. So now, in the original problem, since we're asked, are the costs the same at 3 months, which is what we had found, and they are. They're both $110. So we have found the correct value. Now, here's some extra problems that we can consider, and these are just helpful in how we can identify what is unknown. What do we not know and need to know from our problem? So let's read the first one. You order coffee for $4 and a donut for $1.50 each time you visit your favorite coffee shop. Last week, you spent $27.50 total on coffee and donuts. How many times did you visit the coffee shop last week? Now, in this case, I know how much a coffee costs. I know how much a donut costs, but I don't know how many times I visited the coffee shop, and that's what I'm looking for. So in this case, my x, or whatever variable you choose, is going to represent the visits or the number of visits that you take to the coffee shop. Number 2, Amazon is having a sale on board games. After a 25% price reduction, you purchase a board game for $16. What was the price of the board game before the reduction? So in this case, we know that our board game cost $16 after the sale. We know that the sale was 25% off, but we don't know the original price of the board game, and that's what we are asked to find. So in this case, our variable x is going to equal the original price, and specifically of the board game. Question 3 says the length of a rectangular swimming pool is 75 feet more than the width. If the perimeter of the pool is 360 feet, what are its dimensions? Well, in order to find the perimeter, which is a value that we're given, we need to know the length and the width. And we know that the length of our swimming pool, of our rectangle, is 75 feet more than the width. So in this case, our length is expressed as a term relying on the width. So the thing that is unknown is the width of our pool. Now, in this next part, we need to write our expressions to represent the other unknown quantities in terms of our x that we just determined. So for number 1, we know that we get a coffee and a donut each visit, and we know how much each of those cost. So we can put that in terms of X. So each visit, we're spending $4 on a coffee and $1.50 on a donut. So let me write that out. So 4 times the number of visits is going to tell me the total amount for coffee. And then for the donut, that's $1.50 each time we visit. So that's going to be the total amount for donuts. All right, in number 2, this was the sale. And in this case, there are no other quantities that could be expressed in terms of our original price. We are already given everything else. So in this case, this is where I was talking about earlier. We don't need step 2. We can skip it. And then in the last one, again, we're given that the length of the pool relies on the width, which we said is x. And so since we know that it's 75 feet more than the width, or 75 feet in addition to the width, we can write our length as the expression x, our width, plus 75. All right, I hope you found this video helpful, and I wish you luck as you are solving your many word problems.